welcome to another science video from the Howard. Today we're going to look at the electrolysis RPA, which is part of chapter 6. The first electrolysis I'm going to do is of sodium chloride. So electrolysis is a process that we can use to separate an ionic compound into its elements using electricity. So ionic compounds are when we have a metal bonded to a non-metal, and there'll be ions in that. The metal ions are positive, the non-metal ions are negative. In sodium chloride, we are going to have sodium ions and chloride ions dissolved in water. And when we dissolve that compound into water, the bonds between the positive and negative ions will break. New bonds form between the ions and water, so the ions get mixed up in the water. The important thing here is that once you dissolve an ionic compound into water, or if you melt it, those ions can then move around, so you've got a charge that's moving, so you can then have an electrical current moving as well. So the first thing I'm going to do is put a little bit of sodium chloride solution between my two electrodes. These electrodes are graphite electrodes, and graphite has a free electron that can move, so the graphite can also conduct electricity. If I put the sodium chloride solution between those two electrodes, we can then get an electric current flowing through the sodium chloride solution. So I'm going to use a pipette to put a small amount of sodium chloride solution between the electrodes, and I need the solution to touch both electrodes. Inside the Petri dish, I've also got some damp blue litmus paper, and this is going to be used to test for a gas later on. Right, if I turn the power on then, we're going to get an electric current flowing through my sodium chloride solution. Right, so now I've turned the power pack on, we've got an electric current flowing through my sodium chloride solution, through the electrodes and through the wires. Any positive ions in this solution will move to the negative electrode, and the negative electrode is called the cathode. So because this is a solution, you've got ions from water, the hydrogen and the hydroxide ions, and we've got the ions from the ionic compound sodium chloride that have been dissolved in the water, so we've got sodium ions and chloride ions. So the positive ions in there are our metal, which is the sodium ion, and hydrogen ions are also positive. So those will move towards the negative electrode. When they get to that electrode, the least reactive element will gain electrons and become atoms. And in this case, that's hydrogen. So the hydrogen ions gain electrons, they become hydrogen atoms, and then the hydrogen atoms pair up to become hydrogen molecules, and we get hydrogen gas produced, which we will see as bubbles. At the other electrode, the positive electrode, something similar happens. The positive electrode, which is called the anode, will attract the negative ions. And in a solution of sodium chloride, the hydroxide ions are negative, and the chloride ions from sodium chloride are also negative. So they both go to the positive electrode. At that electrode, the negative ions, or the negative chloride ions, lose an electron to form chlorine atoms, and then those two atoms pair up to become chlorine molecules, and we get chlorine gas forming, which we'll also see as bubbles. Now, chlorine gas can be tested for in another way, which you're going to see the bubbles, but we can also see that the damp blue litmus paper that's in the Petri dish is starting to go red, and then it will bleach to white. So we can prove that chlorine gas is present by having damp blue litmus paper that goes. Okay, and then to test for the hydrogen gas, we could collect it if we had more hydrogen gas being produced, but because there's only a small amount, we've pre-prepared some hydrogen gas, and we can use what's called the Squeaky Pop Test to test for hydrogen gas. So if a gas is hydrogen, it will extinguish a lighted splint with a squeaky pop. So I'll show you now, and hopefully we'll get a nice squeaky pop sound. So in this balloon tube here, there should be some hydrogen gas. So I'm going to light my splint, and then I'll hold it at the neck of the buoying tube and hopefully we'll get a squeaky pop. Nice squeaky pop there. Now this has been running for a little while, we can really see that the damp blue litmus paper has definitely bleached. It's gone from a really quite bright blue to almost completely white. Now I'm going to do electrolysis with a different solution, which is copper sulfate. So we've got copper sulfate dissolved in water. So the copper sulfate has positive copper ions and negative sulfate ions. And as with the sodium chloride, when we dissolve it in water, bonds between the copper ions and sulfate ions break and they form new bonds with the water molecules. So the ions become mixed in with water and those ions are free to move. So the dissolved ionic compound can conduct electricity. So again, we've got our graphite electrodes and they have the free electron that can move, so it can conduct electricity. And I need to make sure that my copper sulfate solution touches both electrodes. You'll also notice that the copper sulfate solution is bright blue. That bright blue colour is caused by copper ions in solution. So if you've got any solution that has copper ions in it, it's normally a blue colour. If I turn on the power pack then, we now have an electric current running through my copper sulfate solution, through the wires and through the electrodes. As before, positive ions in the solution will move to the negative electrode being the cathode. So the two positive ions in this solution are the copper ions and the hydrogen ions, because again it's a solution, so we've got hydrogen ions from water. The least reactive element will gain electrons. In this case, copper is less reactive than hydrogen, so the copper ions gain electrons and they become copper atoms, so after a while we should see copper metal forming on the negative electrode. And again, the negative ions, which are our hydroxide ions from water, and the sulfate ions from the copper sulfate, they will go to the positive electrode, which is called the anode. If there's no halogen or a group 7 element present in the solution, we will get oxygen gas produced at the anode instead. So we're still seeing bubbles, but that gas this time is oxygen gas. So we could have collected the oxygen gas again and tested for it, but testing for oxygen gas we use a glowing splint. So if you have oxygen gas, it will relight a glowing splint, so it will go from just a little bit glowy to a full flame if you put that glowing splint into oxygen gas. Last point to note here is that at the negative electrode we might just be able to see that there's a kind of orangey brown colour forming on the electrode. That orangey brown colour is the copper metal forming that I said would form. So the copper ions in the solution are turning into copper atoms, which is like the metal form on the electrode. Because the ions are going from the solution and being removed from the solution, the blue colour of that solution will get less and less blue over time. And eventually, once all of the ions in solution have been turned into atoms on the electrode, the solution won't be blue anymore and it will be completely colourless.